Hi, I'm Aaron Christian. This is Physics 2211 Lab 5 over collisions. The purpose of this lab is to observe and analyze the motion of an object as it collides with an object that's equal to itself at a constant speed. We will be doing this by comparing the physical experiment to a computational model. Fundamental principles used in this experiment are Newton's second law, which will be used to update the position, and then conservation of momentum and kinetic energy, which says that basically if there's no work done from the surroundings, the kinetic energy and momentum should be equal at the end of the transaction. And then there's the elastic and inelastic collision, which if it's elastic, the loss in kinetic energy will be zero, or basically zero, and if it's inelastic, it'll be a non-zero number. Objective of this experiment is to measure and analyze the head-on collision of the two balls at a constant velocity, to compare observed results with a computational model, and we expect to see some conservation of momentum that are elastic. How we'll be doing this is using the tracker app, and then we'll basically put our system as the two balls, and then the surroundings will include everything, which includes ground and air resistance. The formulas we're going to use in this lab. So we have the velocity update formula, the position update formula, and then we have the kinetic energy formula and the momentum principle. This is the source video that we put into Tracker. The ball is at constant velocity when it leaves his hand. So we recorded from when it left his hand to when it hit the other ball. And then we recorded the other ball from when it hit the green ball hit that ball and until it hit his hand to get the velocity for it. This is our tracker analysis data. So our video was recorded in 60 FPS, we'll use that for iterations in our code. The initial start time was at 0 seconds. The initial position of ball 1, which is the ball that was moving at the very beginning of the video, was negative 0.232 meters, and then ball 2 was set at the origin. And then you have the initial velocity of ball 1, which was 1.33 meters per second, and then ball 2 is the ball that got hit, and the velocity after getting hit is 1.12 meters per second. And then the time of the video was 0.37 seconds. 0.367 seconds. So on this slide we have the tracker data, and in this data we have our information taken from tracker, and we also have the steps. So you can see iteration 2 or iterations. So we have iteration 1, which is where the ball is rolling before it hits the other ball, and then iteration 2 is after it hits the other ball. So you see ball 1 has a velocity of 0, 0, while ball 2 has a velocity of 1.33 meters per second. On this slide, we have the code for before the ball hit and after the ball hit. So on the left, we have before the ball hit, and then at the bottom, you can see it says bang. That's supposed to be where the ball hits. And then on the right, you have the time frame for after the ball hit, and you can see the ball's velocity at the top. On this slide, we have a comparison between the computer model and the real life model. So we have the computer generated model of the ball hitting. So you can see it's just simple hits and then goes essentially the same speed. And then below that we have two graphs. The solid line is the tracker data, and so it's very clean, cut and go, and it's a perfectly linear line. And then on the right we have the real life data, and it's essentially the same at the point of contact, but there's a little bit of a difference. It kind of seems to curve off, and that could be due to resistance, friction with the table. We see that the collision elastically transfers the velocity to the stagnant ball, and then there's a little bit of difference, and potential errors could come from air resistance and inaccurate point masses. Was the momentum conserved during the collision? It was mostly conserved. About 83% of it was conserved, and we took that by dividing the momentum of the first ball divided by the second momentum after the collision, And was the collision elastic or inelastic? We decided it was inelastic since there was a loss of kinetic energy, and in an elastic scenario, there would be no loss. The what if question is, if the ball were to have slowed down significantly, what would be like causes of that? And that could be maybe be like air resistance or maybe a sticky surface that would have caused the ball to unexpectedly slow down. So basically work from the environment.